our final exam is this Garrett right here? Is he here? Okay. Our final exam is gonna be next Monday at 1:30 to 3:30, okay? 1:30 to 3:30. I don't know if there's a class after this class that day, but I'm not like, gonna say, okay, 3:30, turn in your papers. I mean, you know, I'll give you some extra time, 15, 20 minutes to kind of chill. So I don't want you to be all super anxious about the test, but I do want you to be prepared, right? And so we covered a lot of material in this class, but we didn't cover everything because it's impossible. There's just too much stuff, but you did get enough knowledge of cryptography to understand it, I believe. And when you go and do the work out there, then it'll resurface, right? Now, I was interested because I was talking with Osvaldo, right? And he had a job interview, and he kind of shared with me that one of the things they asked him was name the 7 layers of the TCP/IP model, right? So these are
I missed one, but the guy was like, most people don't even get past 2, so you're good. And I was like,
so I mean, so what I'm saying is, and then I remember last semester, Brad Morrison, he went for a job interview and they found out he had taken crypto. And so they asked him to explain the RSA algorithm.
Oh yeah, they asked me a couple algorithms, like just out of curiosity, just to see if I knew them.
Yeah, so they'll do that. So what I'm saying is, you know, the stuff that you're learning is important conceptually. No one's gonna ask you to crank out an ECC or RSA numbers. That's not gonna happen. They want you to understand the concept, right? And that's what's important for this class too. Yeah, we have to do all the math and go through it, but
they also asked me like which algorithms were symmetric or asymmetric, block ciphers and stream ciphers. But they told me like just try your best. Like we don't expect you to know it, cause like you know. But I told them like I was a junior, I'm taking cryptography, and then I told them, and they were like, cool.
Yeah. Yep. So that's what happens. You know, that's kind of what that's what goes on. So hold on a second. I'm going to catch David and what's his name?
Yeah.
Garrett is here, right?
Yeah, because the main guy.
And I haven't seen Abby yet. Is she got her?
It wasn't even a supervisor.
So the test again, like I said, is going to be on during this time period here. And if you prepare for it and go through the home, I actually gave you a sample exam. Right? And so if you look at that, answer all the questions, and look at some of the problems and how to solve them, then you're golden. You're good to go. You know, you can make 100 on the final exam, right? So that's really all I wanted to say about it, other than let's maybe work some problems that people have from this test that I put out. Does somebody have any questions on that? Or do you maybe have some questions on the homework assignment that we're looking at today? Right? And if you don't get your homework assignment done today, I'm not gonna, you know, you can turn it in on Monday, okay? I don't want to, if it's not done today and you feel like you want to play with it some more, you can just bring it when you take your final, right? I mean, I probably should have told you that a couple of days ago, right? You're down there trying to print it out. But yeah, I mean, again, I want you to do the work and I want you to try to understand it. That's your main goal, right? And so if you need the next couple of days to do that, but now don't spend all weekend doing homework number 7 because you know you got to get ready for the test too, right? I mean, I know you have other tests as well, so you know, let's do that. So, does anybody have any specific questions that we can maybe work through to kind of alleviate any concerns anyone might have with stuff? I'm happy to answer any questions.
Can we go over number 6 from exam 2?
The which one?
Number 6 from exam 2.
I don't know what that is. I don't have that with me. But if you give me your paper, I can maybe copy it and see what it is. I don't know what that is. So number 6. So number 6 says 2 public keys. So it is a Diffie-Hellman key exchange, right? Diffie-Hellman key exchange, right? And it's asking us to, it gives us the parameters. P is equal to 397, and alpha is equal to 2, A is equal to 13, and B is equal to 53. And didn't we do this one last time? Didn't we just do this last time, or did we do a different one? Oh, okay. So the first thing that you want to, whenever you have any type of technical problem or something, you're like, well, what are they asking you? What do they actually want to know? And so they're asking you for the two public keys, you know, KA public and KB public. That's what they want to know. And then they want you to have the shared key, which, I don't know, we just call that, you know, share, key share. So those are the three things that we're needing to find, right? So that's the problem that we have to figure out. And so then you look at this and you go, well, how do I solve this, right? And you just say, well, KA public is equal to alpha raised to the private key, which happens to be A, which is A, mod P, right? So that's the answer, right? And the answer here is alpha to the B mod P, and the answer here is alpha to the A, B mod P. So that's the answer, right there, right? Now you have to go through it, okay? So you have to, you want, so if you had your crib sheet, you would say, oh, that's how you do this part. Those are the three things I don't know. And now you just have to then say, well, then you drop these ingredients into the sausage grinder and you turn it, right? And so alpha is 2, A is 13, mod P, and this one is 2 raised to the 53 mod P, which is 397. And then this one is 2. This one could be tricky, right? But this is what the answer that it is. It's 2 to the 13 to the 53, right? Mod 397, right? Now we know that in order to calculate the shared key, this can also be equal to 2 to the 53 raised to the 13th power mod 397. In other words, this is 2 to the 13th is A, so this is actually, this is B. This is B calculating that, and this is A calculating that. That's kind of what you have to understand, you know. And so then you can just put that in your calculator and calculate that out, or you can go through this process of breaking it down, and blah, 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 and you can do all that, you know, raise that, there's all kinds of ways to solve it. For the final exam, I think on something like this, you would just type in your calculator, because these are small numbers that you can do, right? So, does that make sense, Chris, how to do that? So the solution to any problem is finding out, well, what do you know, and what do you not know, and then how do you find that, right? So that's that whole, you know, known, unknown problem that exists in life. Right? Known, unknown, you gotta find out what you don't know, and then drive it up to the corner. Yeah. And so answering the question by analyzing, that's critical thinking. What's that? 7 what?
Yes.
Oh, number 7? So number 7 is where they're asking you to, so it's just a simple XOR problem, right? And what it says is that Alice and Bob think they're clever, and they're using XOR encryption to send information between themselves, right? And to confirm that they're using a common key, Bob sends Alice an encrypted message consisting of this, which is 10, 11, and I'm not saying that right, 0, 100, so she sends him this message, and then Bob says, oh, okay, I'm gonna decrypt it, and I'm gonna send back the decrypted value, which is 0100 and 1010, and then 1011, and then finally 11. And so having those two pieces of information that somebody encrypted or captured during this exchange, all they have to do is calculate the XOR operation. You want to do that. And that basically reveals the key between the two, right? Yeah, so that's it. So this is the encrypted, this is the plain text, and then the key is just the X4 of those two. Okay, so it's encrypted, plain text, and the key. And you just do that. And then once you figure out what that is, that's just going to be 1 1 1 1 1 1 1 0 1 1 0 0 and 1 0 0 1. And then you know that this is equal to what? F, E, C, 9, right? Just by converting hexadecimal. And remember, you have to kind of know hexadecimal code because that's the first level of reading that humans do. We don't read binary code. We read hexadecimal code. And so you have to know how to read these codes so that you can identify patterns and data, right? And so that's kind of what's going on there. Yeah, so that's a good question, yeah. Any other questions that we want to talk about? And remember, it's not just solving it, it's understanding it, right? Understanding the situation, really what you're trying to get, right? So what's that? That's that old saying, seek first to understand before you can come to a solution. Yeah. Anyone else have any other questions on maybe that midterm exam that we need to talk about? A little bit, everyone's good with it? Yeah, okay. Oh, number 8? Yeah, we can go over these a little bit, number 8. And these are always tricky, but these are fundamental for understanding cryptography is looking at how to solve these problems. So like in this example here, 27 times 1/5, or this is 27 over 5 mod 103, right? And so really what this is saying is 27 times 5 inverse mod 105, 103. We don't know what 5 inverse is, right? So we have to figure out what that is. And we have to be able to multiply something, what was it, 5? So we said the inverse of something times something is equal to 1 mod 103, right? So we have to multiply 5 times some number so that when we take the mod of it, it's equal to 1, right? And so what is that number? I don't know what the answer is. Was it 27? Does everyone remember? Was it 27? Over 26?
I think it's 27.
22?
26.
26? So what's 5 times 26? Well, 5 times 25 is 125, right?
135.
So then you have to add 5 more. So that's equal to
130?
130, right? Is that right?
Yes.
130 mod 103 is equal to 1? Is that right? No, that can't be right. Something's wrong. I did my math wrong. What is the answer? So this is what I would do. I I would go and download on, everyone has an iPhone or something, and, I would download this thing called ModCalc, right? ModCalc. And just called Mod Calculator. Okay, this is it. You can't see it really. But then all you have to do is hit that button under the mod, and I'm going to type in 103. So now my calculator is operating in mod 103. Okay? Then I just have to type 5. Let me clear this. I just have to type 5 inverse, and I get 62. So it's 62. Right? And so then the answer is the inverse is 62. So that's what I would do. I mean, you know, we have open resources, and so let's use the tools. So just download ModCalc calculator and then figure that out. But what if you didn't have an iPhone, you got one of these Galaxies or some weird thing and they don't have that app, what would you do? Well, you can divide 5 into 103, and you know, you just have to keep playing around with it, right? You have to just kind of start guessing, but we don't want to guess, right? So go ahead and download ModCalc, or and you would find out that inverse was equal to, is it 62? Is that the answer? And then we have to multiply 62 times 27. 27 times 62 mod 103. So I use my calculator here, and I'm still in mod 103, and I type 27 times 62, and that's equal to 26. So the final answer is equal to 26. So this little tool will allow you to do that. This little modulus calculator, because we don't have the modulus calculator on the iPhone, on the regular calculator for some reason. Does everyone understand how to do that? Yeah? So you can, so we found out that the inverse was 62. What if we didn't have a calculator? What if we didn't have a phone that had that? How would we solve it? Who's got an idea?
Add 103C.
Do what?
Add 103 again and again.
Keep adding, exactly, keep adding 103, so it's 103 and then 206 and then 318, right? And so you have to keep doing it all the way 62 times?
It's 309.
309? Yeah, but still you have to keep doing it all the way 62 times, right? How many times is it?
It's 309 because when 10 is divided by 5, so that's just 1 more than 309. And that will be 103.
There you go. See what she's saying? So something times 5 is going to give us the value. And so what is it?
310.
310? And how do you get 310 divided into 5 goes into 310 how many times? 62. See that? So there's other ways to solve it, right? So you start looking for a way to get in there. So you're looking for 207, 310. You know, you're trying to find a number that would divide into it, right? And so there you go. Make sense? So there's more than one way to skin this cat. Like we said, all of them are ugly and nasty ways, but yeah, there's different ways to do it. And just kind of hack around with that calculator. It's kind of weird. When I first downloaded it, I'm like, what the hell? I couldn't figure out how to do stuff with it. And then I saw that it was calculating in real time every time you answer something. So again, that's part of the process of, let's say you're working on a project at work and you're starting to do some stuff in cryptography. Well, the first thing you want to do is gather your tools. And so you gather modulus, you use that, you start looking up again or XOR operations, and you know, you would do that at your work. You would spend a couple of days gathering tools. And so that's what this final is about, is gathering tools, gathering information that you need to solve a set of problems. Right? That's part of the test, right? So, yeah. Oh, you had a question?
I wanted a kind of an explanation on homework 5, number 6.
Homework 5, number 6,
I have it if you want it.
which says,
Will the previous ECV experiment work on JPEG images? What about TIFF, RAW, GIF? Why or why not?
yeah. So, one of the things that we did, what we did there was we had a bitmap image, right? And a bitmap image is essentially a structure that, so if you look at a bitmap image, and we can look at here in a minute, but if you look at a bitmap image, it basically has some parameters at the beginning. This is for bitmaps, right? It has some parameters here, and then it just has a bunch of pixel values, right? And those pixel values are just a structure of the X times Y, you know, the layout of the image, right? Well, this data right here is telling you the color table and the size of the image. So this information right here is giving you the data structure of how this data is interpreted. Well, when you look at other data structures like JPEG, JPEG is compressed, right? So this is uncompressed. And there are some compressed bitmaps, but in general, they're uncompressed. But this is compressed information, and so there's no real, you know, every run, they have actual runs inside the image that are of all different lengths that go through the inverse process, right? The inverse sign process for calculating. So that won't work in that particular environment because it's compressed. Raw images, would those work? A raw image is when you take a picture and your camera uses charge coupled device, and it says, okay, for this particular pixel, this element, I'm going to put that right there, and that's going to have an energy for it. And so every CCD cell on your when you take a camera, every CCD energy level is put right on there, and there's actually no structure to it. It's just here it is, right? And so a raw image would definitely work. You could take a raw image and do the same thing with that. GIF formats, those are compressed, but there are some uncompressed GIF images. So it kind of depends. Right? The answer is it always depends, right? Does everybody understand that? You know, compressed and uncompressed images and things like that. And so that's why it can work in some cases and it may not work in others. So it kind of depends if the image is compressed or uncompressed is really the answer. Right? Does that make sense? Yeah. So that's a good question. Any other questions on any of the previous homework that we can look at? I was talking with one of the students the other day about a problem that we had, and maybe this will be on the final. And it was from a homework assignment. I want to go back to, I think it was, yeah, DES. It was problem number 3.1 on the DES algorithm. And in our final exam, we have a problem in here somewhere where it asks about the DES. There's like a lookup table. Right? I can't remember what it is. I was just looking at it. Yeah, here it is right here. It's on his final exam, sample final exam. It has this right here. Right? Well, I'm not going to give you that problem. I'm going to give you one similar to it. And the one that's going to be similar is like problem number 1 on chapter 3. And what this problem says is show the nonlinearity between S boxes, right? Does everybody remember that problem? And so what this is saying in this chapter is we wanted to understand that these S boxes are not easily, they're non-linear in the way that they're added. So let's just look up on the internet real quick for S box. Okay, ladies, close your eyes because you never know what's going to come up and type stuff. Yeah, let's just pretend that this is an S box. I guess this is S1, right? So you just never know. I'm telling you, I've been shocked at what I type and then whoa, yes. You know, I mean, I'm sure you've experienced that yourself, right? So let's just pretend that this is our S box. It happens to be S1, and the problem says, given that X1, let's do number 3. It says given X1 is equal to 10, 10, 1, 0, 1, 0, 1, 0, right? And it says X2 is equal to 0, 1, right? So that, or whatever this is. This is 10, right? This is actually equal to 10. So 10 is not equal to 13. So that's showing you the nonlinearity of this operation. So that's probably the type of a problem that you would have, right?
So you basically have to know like the numbers, like to find the numbers in the S box, right?
Say that again?
So I'm saying you basically have to know like this is 6 and this is 12. Like to
Yeah.
know.
Yeah, you have to know hexadecimal. You, as a computer science person, or information technology, whatever you want to consider yourself, I consider yourself computer science people, scholars. You have to know hexadecimal because that's what computers are. And well, that's the first level of interaction between a human and a computer is that hexadecimal, right? You know, when you're looking at data, we're looking at data structures, right? Because computers interpret data structures, humans interpret data structures. They look at machine code, binary. We can't really look at binary. So we're pulled all the way back to, hexadecimal code, right? If you study computer science, we study in another class that I teach, we talk about that when people would program computers back in the 50s and so you had to code them in machine language originally, and then assembly code, and then the very first programming language. Anyone remember what that is? Fortran. Fortran was the first program language that jumped us from machine code, assembly code to a higher level language. So yeah. Crazy stuff. Yeah, so I would try to remember the hexadecimal table. There's only 15 numbers, and you should be able to recognize them straight away, right? But does anybody have any questions on that? So that would be a good question that I would, just exactly like this. You just have to go through this process, of looking at it, interpreting it, and then. So I'll give you this exact problem, not this exact problem, but one like this that you just have to crank through to show understanding of this thing. Right? No, it's not a bad problem. And yeah. And then so looking over the sample final, you're gonna have to learn how to calculate phi of m. We did that in our midterm. You're going to do an RSA problem, and you're going to use Fermat's little theorem, right? You're going to have to know that, and so you want to write that down. And then and then Diffie-Hellman key exchange, which we just did. And the one that I don't have on here is the ECC, and so I think we'll have a regular ECC. But it won't be too complicated because what do you call it, it takes a lot of stuff, right, to crank through it. But what you can do is you can work through it and then you can check your answer using the internet, using one of the internet calculators, right? So it's just a matter of getting your information together, understanding the problem, and then just putting it through the sausage grinder, right? It's just a, grab and go type of thing, right? And then I like having these essay questions, like, you're walking across campus and you bump into Sister Walter and the president, and they're asking you, or your roommate says, hey, what's this RSA thing? How does that work? And then you tell them. And then they say, well, what is this ECC thing? And then you have to write, okay, how does ECC work? And then maybe they ask you, what's with this quantum computing? And how are we going to defend against that, right? So then you'll say, well, so we went from RSA, discrete logarithms, and then we went to ECC, which is multi-point bouncing around, right? Which is complicated. And then we say, oh, now the next phase is lattice cryptography, multidimensional lattice with vectors. And we exchange vectors rather than points. And so it's really quite understandable as you're going forward. And like I said, the world will be quantum cryptography going forward. If you take a crypto class in 5 years, there's going to be another chapter on lattice encryption. It's going to be full of math and crazy stuff. But there'll be an application side, just like the ECC, where we can actually, we don't have to go through all the math, but we can at least understand the application of it and go through. That same thing will exist for whichever lattice encryption algorithm we use for quantum resistant computing, right? There'll be a quantum resistant computing cryptography algorithm that will be released by the government in the next 5 years, and it will be mad awful math, but there will be an application side which will be understandable to people who understand cryptography, right? And so that will be you guys, and so you'll be able to do it. And in 5 years, you'll be able to read the implementation of it quite easily.
Questions?
Okay. Oh, you're the first one to turn it in, and had you come to class on time, you could turn it in late. You could turn it in next Monday.
Wow.
You said what Andrew was thinking. He said, wow, with his face.
Oh.
But I'll take it if you want. But maybe you can hang on to it until Monday. Okay, so any other questions? Yes, sir.
The last final, you asked about blockchain technology. Are you going to ask about that in this one?
No, because we didn't really talk about it, so I'm not going to ask about blockchain technology, because unfortunately, we really didn't get into hashing algorithms. But there's, so we didn't cover everything, but that doesn't prevent you from doing your self-learning. So you can easily go on the internet and download 500 million blockchain videos and hashing, so yeah, so we covered some good stuff. But I won't have anything on blockchain technology, but there'll be questions on, like, explain to Sister Walter how RSA works. Because that's the question you're going to get in an interview, okay? They're not going to ask you to calculate an RSA equation, but they're going to ask you about it. And so then you would say, well, that's one of the asymmetric algorithms for exchanging keys, blah, 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 this is a public key, private key, so you just kind of make up some stuff. Just start writing, and then, eventually I'll get tired of looking at it and go, yeah, great, yeah. That's good. But we will have the class, we will have the test in class, and I was just looking at this. I got this in the mail. I picked it up on the way into work today, and it has ChatGPT fixes, how to fix anything in Linux using ChatGPT, and then there's there's how to write chess programs, And then there's also something in here about, you know, different, becoming a C++ chess master. Now this,
I can't do
this,
that.
I have this in my hands here, and you're like, oh, let me see that. But this is free. You can get this from the public library, right? You can go to the San Antonio Public Library and just set up an account, and you can download this and 1,000 other free magazines, right? You don't have to buy something like that. That costs me like $100 a year, but you can get it for free. So just go to the San Antonio Public Library and set up an account, and then they have Better Homes and Gardening, you know, Cosmopolitan, all the Playboy. I don't know if they have all that. All these magazines are free.
That's at the library.
I don't know if they have that. I'm just joking. I
I'm
don't
trying to
think
get
that
into
is.
this.
But what I'm saying is, all these magazines are there that you can get for free because you're a citizen of the city. And so go ahead and you can download all that stuff, and cut and paste it and all that stuff. So anyway, yeah, it's called Linux format.
That was fun though.
And it also talks about faster Ubuntu, you know, a smaller, lighter weight Ubuntu, so you can throw it on an old PC that you have in your garage that you're going to throw away, stuff like that. So, yeah. So, any other questions? I think then I'm done talking then, and you can just head out. You guys can go get a burger or a hot dog or whatever it is that they have, right? So. Yeah, thank you, and I'll see you all next Monday, and we'll have our final exam. I'll bring some candy bars or something, so, because like after an hour, we can run it on a rock time, so we want to keep that back up.
Video games for the night, and then tomorrow's Tuesday.